Okay, this is topic number 8 called congruent triangles. Just so you know, this is going to be a cheat sheet for what we're going to be doing the next few weeks. At first, it's not going to make too much sense, but just bear with it, and we will get through it, and it'll make more sense as the weeks go along. Okay, so the first thing we want to look at is how we establish what a triangle is. So I'm going to do this on the side. Don't write this down. Just watch. This first part is just so you can kind of get an idea of what is what. If I were to draw a triangle like this and I call this A, B, C, notice that A, B, and C are all in capitals. That's because they are points. They are also can be a reference to your angles. So this would be angle A, this would be angle B, and this would be angle C. So it's point A, point B, point C. It also reference angle A, angle B, angle C. On the opposite sides of these angles, so for example, if I go completely opposite of that angle A, I can call this little side A. On the opposite of angle B, I can call this little side B, and the opposite of angle C, I can call this side C. Notice that the sides are all in lowercase, A, B, and C, and the angles are all in uppercase. Angles measure how open an angle is, whether it's an acute angle or an obtuse angle. Sides will measure how long something is. Okay. All right, so that takes care of these right here. Let me go ahead and start going into these congruencies. So very important that we keep track of how stuff is written. So what do I mean by that? Let's go ahead and try to match up these sides. You see this angle A, or so this point A right here? Because this is on the side that has a tick mark and a triple tick mark, the other side that matches it would be over here at D, because it also has a single and triple tick mark. So A and D, we would say, are matching spots. The same thing with B and E. Those correspond to one another because that's a single and a double. This one is a single and a double. And then obviously the whatever's left over would match up. So we have point C and point F matching up with each other. Let's go ahead and write some congruent statements. I know that this segment right here, segment AB, is congruent to segment ED. I'm going to go ahead and write that on the side. It's technically not right. So what do I mean by that? AB is congruent to ED. If you were to write this on formative, it would mark it wrong. The reason why is because order matters in geometry. So when I say A, B, and ED, even though I am referencing the same sides, I'm not doing it in the correct order. When I said AB at first, I went from the green and I went over to the pink. That means on the other side, you need to start at the green and go over to the pink. You need to keep it on the same order. So I should be writing DE if my first statement is AB. So let me go ahead and write that again. AB is congruent to DE. That takes care of my single tick mark side. If I wanted to talk about my double tick mark side, here is segment BC. Notice how I went from the pink to the yellow. That means on the other side, I would have to go pink to yellow. I would go EF. So I would write segment BC is congruent to segment EF. And then the last one we have is the triple tick mark. Triple tick mark, it doesn't matter if you go this way or if you go this way, but once you pick one, you got to be consistent. So let's say I go yellow to green. Then on the other side, I also need to go yellow to green. So I'm going to go segment CA is congruent to segment FD. All right, so hopefully we got an idea of what I mean by keeping stuff in the correct order. All right. Now, as far as these, this is what the notes are going to look like. We're going to go over quite a few notes today. It's going to cover this first page, and then we do have a backside, which I'll cover in a separate video. This is going to be like your cheat sheet. It's going to tell you what kind of congruences we have and how to tell what they are. Later on, we're going to actually use the congruences, but right now, I just want you to focus on how to identify what kind of congruent statements I have. And when I say congruent statements, I mean these two triangles. These theorems will show you how you know whether triangles are congruent or not. Let's just jump into it, and then we can go off of that. So notice that I had a side, and a side that matched up with a side, a side, and a side. So you have one set of sides, two sets of sides, three sets of sides that are congruent. We call that side, side, side. So for the first congruency, we have side, side, side congruency. This is when we have three pairs of congruent sides. If you can establish that you have three pairs of congruent sides, then you know those triangles are congruent. So what I'm saying is these triangles are for sure congruent because I have three sets of congruent sides, 2 and 3. That means it's the exact same triangle, it's just in a different spot. Okay, let's look at the next one and see how that differs. I like to check off my sides first. So the first thing I notice is this side is congruent to this side. Okay, so that's one side. Awesome. Do I have another side? Yep, I have another side. This side is congruent to this side. So that's two sides so far that are congruent. And then when I try to look for that third side, like I did on the last one, I don't have it because there's no markings here. So I only have two sides that are congruent. So if I only have two sides are congruent, what else do I have? Well, they did tell me that these angles are congruent right here. Angle B is congruent to angle E. So I had two sides and I had an angle. If I were to actually write these down as far as sides and angles, it would look like here's a side, here's an angle, here's a side. I want you to notice that in this picture, the two sides have that angle sandwiched in between. I need to make sure that I write it that way. Like the angle needs to be in between the two sides. So we're going to call this second theorem side angle side congruency. What that means is if you're able to establish two sides and the angle in between the two sides to all be congruent, then I know the two triangles are exactly the same. They're just in different spots. So this is when you have two pairs of congruent sides and the inclusive angle. When I say the inclusive angle, what I mean, not inclusive, included, I'm sorry, and the included angle. When I say included angle, I mean the angle in between. The angle is going to be in between the two sides. Okay. All right, let's take a look at the next one. I'm going to go ahead and establish the sides first. I know that this side, side FE, is congruent to this side, side CB. As far as sides are concerned, that's it. I don't have any other sides. So what else did they tell me? Well, they told me that these angles are congruent. Angle B and angle E are congruent. I have another angle. They told me that angle C is also congruent to angle F. So what did they give me this time? They gave me one pair of sides, the green ones, and then they gave me two pairs of angles, the pink ones and the yellow ones. So I have angles and sides. If I were to kind of jot them down, it would look like this. I want you to notice that the angles have the sides sandwiched in between. So even though I have two angles in one side, you want to make sure that when you write your S, the S is in between the two A's because like it's telling you the position of where the side is at. And that's super important when you do these problems. So this is going to be our third theorem. This is going to be angle side angle. Notice that when I did that, the S is in between the two angles because that's telling you that the side is sandwiched between the two angles here. Okay. So if I have angle side angle, then I know the two triangles are the exact same size, but maybe in a different spot. So angle side angle is when you have two pairs of congruent sides. Sorry, two pairs of congruent angles and the included side. And again, when I say the included side, I mean the side is sandwiched in between the two angles. All right, so that takes care of three things. Let's go on to our fourth theorem. Like last time, I'm going to go ahead and focus in on the sides first. I noticed that this side is congruent to this side. AC is congruent to DF. As far as sides are concerned, that's it. That's the only side they gave me. Angles, I know that these top angles are congruent. Angle B is congruent to angle E. And I know angle C is congruent to angle F. So what did they give me this time? Well, they gave me one side and two angles again. But this time, when I start writing my stuff, like if you notice the angle, and the side is not sandwiched in between the two angles. And I know you're looking at that ASA and you're going, wait a minute, the S is in between. No, 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 look, the angle's here, but the side is over here. It's not sandwiched in between the two angles. If it was sandwiched between the two angles, it would be right here and it would get stuck, okay? So the side is not sandwiched between the two angles. When the side is not sandwiched between the two angles, you're going to call that one angle, angle, side, okay? Angle, angle, side. Notice that the side, in this case, is not written in between the two angles like it was on this case where the S is in between the two A's, okay? We don't ever write SAA. I know that maybe that might be an option for you, but no, we like mathematically, we just never use that. We just call it angle, angle, side. It means the exact same thing, and that's the way mathematicians will go off of it. Okay, so if you have two angles and a side, then I know that you are having two triangles that are the exact same size. And in this case, you have two pairs of congruent sides. Oh my gosh, I did it again. Two pairs of congruent angles and the non-included side. When I say non-included side, I mean that the side is not sandwiched between the two angles. All right, so that takes care of our first four theorems. We do actually have one more, and that's for right triangles. On right triangles, remember, let's just kind of go over this. Anything that's touching the 90 degrees is considered a leg. Anything that's not touching the 90 degrees is considered a hypotenuse, okay? So this side right here is touching the 90 degrees. We call that a leg. This side right here is touching the 90 degrees. We call that a leg. This side right here is not touching the 90 degrees, so that one is called the hypotenuse. In order for you to be able to use this next theorem for triangles, you just need to establish that you have a hypotenuse and then you have a leg that are congruent. Just an H and an L, okay? So this is going to be called the HL theorem. This is theorem number 5. HL theorem, you need a hypotenuse and you have a leg. Now, if you notice down here, this leg, they don't match because there's no symbols there. So unfortunately, I can't use this one. But I do have this leg being congruent to this leg. And I have this hypotenuse being congruent to this hypotenuse. So do I have a hypotenuse? Yep, because they match. Check. Do I have a leg? Yep, because they match. So because of that, I have the hypotenuse, I have a leg. I can go ahead and say I have HL. These triangles are for sure congruent. And this is when you have a hypotenuse and you have a leg. Then the triangles are congruent. Okay, we're going to start getting into proofs. Right now, we're just going to establish how do you know sides are congruent. Okay, so there's 3 main reasons why sides are congruent. There's more, but the ones that we use a lot is these 3. The one we use all the time is it's given. What do I mean by it's given? Like they'll literally tell you 2 sides are congruent. Like they'll say, oh, AX is congruent to YB. If they say something like that, they're literally telling you they are congruent. That we say, oh, it was given to us. Also, from the picture, they'll draw it on the picture. For example, here they gave me a double tick mark and a double tick mark. By showing it on the picture, they're telling you right away, hey, those sides are congruent. So we would say, oh, it was given to us, right? Like they told me in the picture. So that's the reason that students love the most, because those are easy points, okay? Reason number 2 why sides are congruent is because they'll tell you something is a midpoint of something else. Now, that one is not given, all right, because you have to kind of like reason your way out of that one. So let's look at reason number 2. It says M is the midpoint of AB, and I have a picture for you right here. Notice that on the picture, they're really not telling you which sides are congruent. If you didn't know what a midpoint was, you wouldn't be able to figure this out. But they did say M is the midpoint of AB. And so I'm going to go ahead and put my green dot right there on M. What's special about a midpoint? Well, the midpoint means it's right smack in the middle. And that's great, but more importantly, since it's right smack in the middle, that means those two sides are exactly the same. So because it's a midpoint, I can go ahead and put my own tick marks and say, therefore, these two sides must be congruent because a midpoint cuts it in half. So the two sides on either side are exactly the same size. Because it's a midpoint, I can go ahead and write AM is congruent to BM. This segment on the left must be the exact same size as this segment on the right. How do I know that? I know that because by definition of a midpoint, that's what a midpoint does. This was not given to me. I had to use some logic in order to figure that one out. Okay. So there's an example of you showing like, oh, they didn't tell me, but I know from them, I was able to figure out that those two sides are congruent. It was not given to me. All right, so that's the second way we know sides are congruent. The third way we know sides are congruent is when a shared side is congruent to itself. And that's going to be a little bit difficult at first to kind of get used to. Like, wait a minute, why do I have to say that? But later on down the road, it'll make more sense why I have to say it. So here's two triangles. And the best way I can show this is by kind of drawing these a little strategically. There's the triangle left on the triangle on the left and the triangle on the right. Let me go ahead and highlight the triangle on the left. The triangle on the left looks like this. And then the triangle on the right looks like this. Now, they don't have any markings, but I know for a fact that there's two sides that have to match up perfectly. Like they have to be the same size. And for those of you guys who are saying, oh, yeah, it's the one in the middle, that's right, right? Because this side over here has to be the same thing as this side over here because it's the same line. So I'm going to highlight that one in green. I'm going to highlight it on both sides so it kind of stands out. And I know for sure that on the left side, the segment XY needs to be congruent to on the right side segment XY because it's the same stick, right? Like it's the same segment. Of course, it's going to be equal to itself. Now, in geometry, we don't say, oh, because it's itself. We have a property that we named it. We say XY is congruent to XY by reflexive property. Reflexive property is the property that allows us to say that something is congruent to itself. Just realized I didn't write this over here, definition of a midpoint. And here it's by reflexive property. Okay, I'm going to do one more thing just so I can help you out on the homework. On the homework, there is, do not write this down on the notes, you can just watch. There are problems that I like to call bow tie problems. They look like this. And notice that on this picture, absolutely nothing's given to me. There was no markings on this thing at all. And yet, even though there's no markings, I know for a fact that two angles are congruent. And hopefully you're noticing like, oh yeah, for sure, these angles are congruent. So on bow tie problems, even though they don't mark it, you should know that this angle is congruent to this angle because of vertical angles. So that's like a hidden one that you need to put there in your mind. So that way later on you can match it up with one of these theorems. All right. And once you start looking at the homework, it'll make more sense. All right. That's all I have for today. As always, if you have any questions, please feel free to ask.